Hey guys, we're back. This is adding algebraic expressions part 2, and we left off with the algorithm for adding 7/10 of x, which is our first diagram, plus 3/10 of x. So we were adding 7 little pieces plus 3 little pieces that are 1/10 size. So we get 10/10, and of course we can't have 10 units in any particular place value. We have to regroup and move it to the next place value, which is the ones place. So 10/10 is 1 whole, and that is x. So basically we are adding the coefficient and keeping the variable. Okay, let's go on to the next one. 9/10 p plus 7/10 p. So our entire bar is 1p. Okay, and our coefficient on p is 1. We don't have to write a 1 there, but we can write 10/10 p. And I am interchanging fractions and decimals, just because I think if you had to actually draw this without it being separated, it's easier if you say 9/10 and then write it as a fraction. So let's just denote 9 pieces of the bar p. And that will be 0.9p, okay? And we're going to add 7/10 p to that. So we only need 1 more tenth to have a whole bar. So when we add 7/10 to this, which will be here, we know that we are going to have 1 whole bar plus more, right? So if we add 7/10 to 9/10, what's going to happen is we are going to regroup and have 1 whole tenth, and how many additional? Because 9 plus 7 is 16. 16/10 would be 1 whole plus 6/10 more. So in our total 2 bars, we have 20/10, because 10 plus 10 is 20. And if you take your 16/10 and take it away from 20, you can just reduce it by 4. So you could count 16 if you'd like, but Miss Bryan is just going to denote 16 of these, 9 plus 7. And I'm going to write it as 1 and 6/10 p. Because again, I can't have 16/10. I have to regroup that and put the 1 in the ones place. So 9/10 of p. And now I'm going to add them as decimals, lining up my place values. Oops, this should be 7/10 of p. And when I add my 9/10 plus my 7/10 of p, I get 16/10, which means I regroup it, carry the 1, and I get 1 and 6/10 p. So again, when I'm adding decimals when I'm adding algebraic terms, which are variables, I add the rational coefficient, add the decimals, keep the variable. Let's turn the page. And I'm going to erase this from my earlier period. 1/2 of a plus 1/4 of a. So again, my entire bar is going to be a, okay? And that's a. Okay. And 1/2 of a is going to be out of these 4 bars 2, right? This is 1a, which is 2 over 2. So we're going to denote 1/2 of a. And in this case, we're adding 1/2 of a to 1/4 of a. So my entire bar is a. And then this, of course, this is a. And this is 1/4 of a. Okay. So why can't I add 1/2 and 1/4? Like you and your friend go and get pizza. And the guy says, "Here's yours, Susie." And Susie gets a piece this big. And then here's yours, Julie. And Julie gets a piece that big. Well, what are you going to say? Are you going to say, "I'll pay $3 for the 4th"? No, you're probably going to say, "Hey, pardon me. My piece is about half as much. I like to have the larger piece because they're not the same size." So, finding a common denominator is what we do to enable us to add fractions. So in this case, we can see that if you take 1/2 and cut it into halves, you actually get fourths, okay? So 1/4 plus 1/4 of A. That's 2/4 of A. 2/4 is an equivalent fraction to a half. And we're going to do the algorithm for that, or the math. And how many fourths do we have of A? 3/4 of A. So the total is A. That's our total bar, 4/4. But when we add it together, we get 3/4 of A. All right. So 1/2 of A. And we're going to write these fractions vertically so that we have an opportunity to show our work getting the common denominator, okay? So what is the least common denominator for 2 and 4? It's going to be 4. 2 goes into 4 2 times, okay? So 2 times 2. And what I multiply, the factor I multiply the denominator by, I have to multiply the numerator by in order to get a equivalent fraction here. So 1/2 is equivalent to 2/4 of A. Same fraction, just different denominator. And then we already are dealing with the fourth. That's our common denominator, 4. And then when we add fractions, they're the same size piece. And so we just say 2/4 and 1/4 is 3/4 of A. So when I'm adding algebraic expressions with fractional coefficients, I use my normal algorithm or rules for adding fractions, finding a common denominator, and then I just add and keep the variable. Okay? All right, let me erase this from 6th period. Okay, m plus 2/3 m. What is the coefficient on the variable m? 1. Good job. Okay, sure, it's 1. 1m. So when we look at the bar model of 1m, 1m is how many thirds? 1, 2, 3. So 1m is the same thing as saying 3/3 m. Okay? And then we're going to add to 1m 2/3 m. Okay? So here is our m. We're going to add 2/3 to that. Okay, so how many total, oops, I put 3/3. How many total thirds is that going to be, guys? 2/3 m plus 3/3 m is 1/3 m, 1/3. And mine is a bit messy with this mouse. And I'm going on my 4th one. And my denominators tell me the size of the piece. 5/3 m. Alrighty, there we go. So you write that down. I already had it. And now I'm going to perform the algorithm, which is just the math. So I'm going to write 1m, and I know that's equivalent to 3/3 m, because I want to know how many pieces I actually have, plus 2/3 m. And when I write it vertically, it's much easier for me to see. So 3/3 m plus 2/3 m. How many 1/3 size pieces? 3 plus 2. 5/3 m. Okay, guys? So pause the video if you need to. Now what I'm going to do is I'm going to reduce the size of the page. And that way, if you happen to not have this packet, I will show you and you can screenshot it. The next page, which I'd like you to do for homework. So, as practice. And you are really doing well. This is what we did for our ticket out the door 30 and 31. So pause the video and write this problem, these 5 problems down. And then on the next page, we have these problems. Pause the video, write them down on a sheet of paper. And 7 through 10, pause the video, write them down on the sheet of paper. This is your assignment. Thank you for watching, and I will catch you for the next video. Take care, guys. Bye.